Hey guys, this video is all about geometric sequences. Our last video was about arithmetic, which was a list of numbers that had a pattern of adding a number each time. Geometric, the key here is that they are being multiplied by the same number each time. That's called the common ratio, and we will abbreviate it with a letter R for ratio. So here's some examples of geometric sequences. So when you go from 1 to a half to a fourth to an eighth, since we are getting fractions here, we're going to be multiplying it by a fraction. Since the numerator is not changing, the numerator is 1, the denominator is changing. Just look at how that's changing. Is being multiplied by 2, which means R is 1/2. Another way you can get it that's almost doesn't involve even thinking. You just have to take one of the numbers and you divide it by the number before. So take any of the numbers. We could do 1/8, and then we are going to divide it by the previous number in the list, 1/4, and when you divide that, you get 1/2. If you would have done the same thing, no matter which two numbers you choose, 1/2 divided by 1 would also be a half. Just another easy way to get what the ratio is. Alright, so same idea here. 10 to 100 to 1,000, that's being multiplied by 10. But since it's changing sign, it goes positive, negative, positive, negative. The way that you do that is by multiplying by a negative each time. That's how you're going to change the sign. And that same trick would work. You can take negative 100 divided by the term before, and obviously that's going to be negative 10. So the formula for a geometric sequence is a1 times r to the n minus 1. Similar to that formula we had in the arithmetic sequences. Just obviously now this involves multiplying, and multiplying with an exponent because you multiply each time. And just like our previous lesson, a1 is the first term, r is the ratio we were just talking about, and then n is just this step, what number term we're looking at. So to find the seventh term, we need to know the first term. We need to know r. So from one step to the next, that's being multiplied by 3, and then 3 again, so r is 3. And then n minus 1, and n in this case is 7. So that's 2 times 3 to the 6th power. So when you multiply these out, you do exponents first. And then times 2, 1458. So these do get large quickly because of the exponent, because it's multiplying each time. So multiplying by 3, our next number is already getting pretty big. It's going to be in the 50s, 54, and then times 3 is going to be 150, 162 actually. And then keep multiplying. So multiply a few times, it's going to get large quickly. And that's because of the exponent, like we said. Alright, find the sixth term. So we need to know the first term is negative 5. Then we need to know r. Notice it's changing. Negative, positive would be the next one. So r is negative, and then just looking at the numbers, it's going to be 4. And then to the n minus 1, so that's going to be 6 minus 1. So that's negative 4. Make sure we put our parentheses here, otherwise calculator will not handle the negative correctly. Oops, not squared. To the 6 minus 1, so that's to the 5th power. And then multiply by negative 5. And we get 5,120. So we can find sums. Finite just means it stops. It goes on for a certain amount of time and it stops. We did the same thing in our previous lesson yesterday with arithmetic sequences. We had that formula. This formula is a little different, a little more complicated, perhaps. More exponents, harder to multiply out, but same idea. All right, so here is our list of numbers. And then to make it easy, it's showing us that they are, R is 1/2 here. Just showing it pretty easy here because they're just using exponents. So A1 is 1/2. 1 minus R, R is 1/2 to the n. So then we also have to look and see that this is going up first, second, third, all the way to the 10th. So n is 10. Over 1 minus R, R was 1/2. So we just need to multiply this out. Again, start with exponents. If you do a little bit of work with this first, like 1 minus 1/2 on the bottom here, that is 1/2. And then since there's a 1/2 on top and bottom, they can cancel out. So we just have to do this calculation here of 1 minus 1/2 to the 10th. So let's start with that, 1/2 to the 10th. I'm going to do 0.5 because it's easier to type. To the 10th power. And it's 1 minus that. So 1 minus answer. It is a decimal, but if we change it to a fraction, it's going to be a little bit easier. 1023 over 1024. These can usually be written as fractions, and it's easier to write that way, be more precise. You're not rounding a decimal or anything. All right, same idea. We know A1, and we can find R, and then we're told that first 15 terms, so that's n. So A1 is 1/4. And then we need R. So when you see that it is alternating positive, negative, we know that R is going to be negative. And it is the numbers are getting larger. They're getting multiplied by 2. To the n, which is 15, over 1 minus R. R is negative 2. So do a little bit of work here. 1 minus negative 2 would be 3. And this is going to be 1 minus negative 2 to the 15th. And again, you either need to use parentheses or pay attention to your negative sign. It's going to be negative to an odd, which should be negative. It's going to be a huge number, though. So this is 1 minus negative 32,768. And then that's 1/4 with a 3 in the denominator. Fraction up here in the numerator, you can take the numerator to the numerator, but the 4, you can move that down to the denominator. And then that's 1 plus. So that's going to be 32,769. Or you could just write it as 1 minus the answer in your calculator if you wanted to. And now we're dividing by 12 from that work we did before. Or you can multiply by 1/4 and then divide by 3. Answer is going to work out the same on your calculator. And if you want a fraction, just change it to a fraction. If you want the decimal, you can write it as a decimal. but typically I like fractions for these. Alright, so here's a weird idea that you can add up, find the sum of an infinite geometric series. So this series, the list that you're adding up, goes on forever, but you can add them up. So that can only happen when the numbers keep getting smaller and smaller and smaller. So r has to be less than 1. Doesn't matter if it's positive or negative, just absolute value of r has to be less than 1. And then we say that it converges, which means you can find the sum. If r is greater than 1, absolute value of r is greater than 1, then it diverges, which just means you cannot find the sum. So as the numbers get smaller and smaller, you can add them up, because when you think about going out to infinity, it's like you're adding up numbers that are getting smaller and smaller. So basically it's like you're adding 0 at a certain point almost. Really strange concept, but I think it helps you to start understanding the concept of infinity. Alright, so here's a infinite series. You can see that this is adding up numbers, and on this r is 2, which means this is going to diverge. You cannot add this up because r is bigger than 1. Absolute value of r is greater than or equal to 1. That's what we're looking for. So this is going to diverge, which means we cannot find the sum. It's just going to be like infinity, because you keep adding up bigger and bigger numbers. However, something like this, where the numbers get smaller, it adds up. You can figure this out because this has an r, a ratio of 1/2. We've actually done this sort of problem before. So when you add all of these up, the first term is 1/2. We can use that formula that we had here, which, if you look at this formula compared to the other one, the only thing that's missing is the parentheses that were up here. So I think that makes it pretty easy to remember. It's just a1 over 1 minus r. So that's a1 over 1 minus r, which is 1/2. So that's 1/2 over 1/2, which is... Whoa, that was weird. So when you add up all these fractions, you get to 1. So the idea with this, and I'm going to show you with a circle here. Alright, so with this, we're taking a look at a circle. Let's, I don't know, for fun, let's, I guess, imagine it's a pizza. So if you start with 1/2, this could be, for example, each time you go back for seconds and thirds and fourths, another piece of pizza, another slice, another whatever, another plate, you can only take less than the amount that you can take half of the amount you took the last time. So this would be like something I would tell my 12-year-old, for example, since he does go back over and over and over again, and I imagine he's got to be getting full, so I would tell him take less. So you can start with half the pizza because he said he's going to eat the whole thing or whatever. But say, okay, start with half. He takes half and he eats it, so it's gone. And then he goes back and he gets more, so he takes half, again, half of what was there, and eats it. Now, half of what was there, that means a fourth, which is what that fraction represents there. Then you can go back again and take half of the remaining pizza, which half of a fourth would be an eighth. Matches up with our numbers there. And then you go back again, you can take half of that, and eat it. Half of an eighth, that would be a 16th. And then you go back again, and you can take half of that. And just imagine you keep doing this half and half. Now the slices keep getting smaller, and you keep taking half of what's there. You're never going to eat more than the entire slice of pizza, or the entire pizza, not the slice, the entire pizza. So that's the idea. You keep taking half of what's left, eventually, infinity. So when I say eventually, that means infinity, forever, eternity. You'd eat the entire pizza. In real life, that would get down to like crumbs or something, and at that point, it's just a crumb. So that would happen pretty soon here, now that we've gotten like 1/32 of a pizza. So hopefully that helps illustrate why this adds up, even though we keep taking more and more pizza. All right, here's another one. I think this might also help kind of understand what's going on here. In this case, r is, now notice the numerator is not changing, the denominator is, so that's 1/10. You're multiplying 10 to the denominator each time. Now, this really is going to make sense. Now, obviously 1/10 is less than 1, so that is going to converge. If it doesn't converge, then you just stop. It diverges, and that's it. So since this converges, we can find the sum. So what we're going to actually do is, if we just look at this, 3/10 is 0.3. And then 3/100, that would be 0.03. And then 3/1000, that's 0.003. And 3/10,000 would be 0.0003. So when you add these up, remember you line up your decimals and add. Well, this 3 is going to line up with all zeros. This 3 is going to line up with zeros and the rest of them. So what that actually is going to equal is 0.3, and then 3, 3, 3, and so on. The further we go out, the more 3's we add on. And just from your knowledge of repeating decimals and stuff like that, you should recognize that 0.333 repeating is 1/3. If we use the formula, A1, which was 3/10 divided by 1 minus r, we get 3/10 divided by 1 minus 1/10. That'd be 10/10 minus 1/10 is 9/10. We can do this by hand. You would flip the bottom fraction and change this to be multiplication. Those 10's cancel out. You get 3/9, which reduces to 1/3. So the formula gives us the same answer that we would expect by just looking at the decimals. And there we go. All right, this one's on here kind of just for fun, because this is, I think it's super interesting. Same thing, 9/10 would be 0.9, 0.09, 0.009, and then so on. So obviously this would turn into 0.9999, repeating forever. So 0.9 repeating forever is what that sequence equals, which as a fraction, it's kind of hard to write. So let's just say 0.9 repeating forever. Now here's the interesting thing about it. If you take the formula, 9/10, so that's A1, over 1 minus r. 1 minus r, r was 1/10, the same as before. So that's 9/10 divided by 9/10. 9/10 divided by 9/10 is 1. So what this actually does, this is one method of showing that 0.9 repeating equals 1. Kind of weird, but that is what it is. 0.9 repeating equals 1. All right, so let's get into some more examples here. We'll find the sum A1, and then R would be 2/3. You multiply the top by 2, the bottom by 3. Top times 2, bottom times 3. So R is 2/3. Since R is 2/3, that's less than 1, we can use the formula because it's converging, or it's a convergent series. So using our formula, we got A1, which is 1, over 1 minus R. So that's 1 over 1 minus 2/3. That would be 1/3. And then to solve this out, you would flip the bottom fraction. So that's 1 times 3 over 1, which is 3. So this adds up to equal 3. Find the sum of the series. It goes on forever. Here's A1, but R is, that's getting multiplied by 3. So since R is 3, that right there, we just stop because this is a divergent. It's 3. It's greater, the absolute value of R is greater than 1, so it's divergent. It's a divergent series. So there's no sum. You can't solve it. So in order to solve it, the terms have to get smaller, not larger. That's really what we're looking at. Okay, so this time, 10 to 2, divide by 5. Divide by 5, you get 2/5. Divide by 5, that works. So that is R. You're divided by 5, which means 1/5. Multiplied by 1/5. So our sum, which means it is convergent, so we can find the sum. You take A1 over 1 minus R. So that's 10 over 4/5. Type it into your calculator or solve it out. It's 10 times 5 over 4. That's 50 divided by 4. And that can be reduced to 25 over 2, or 12.5, but let's leave it as a fraction. All right, so here's a word problem, a real-life sort of example that would work using the same idea. Looking at profits, how much money your business is making. So 30,000 the first year, and each year he makes an additional 5% over the previous year. So each year it's 5% more. So it's the 30,000 plus 5%, which is 100% plus 5%, which means R would be 100% plus 5%, 105%, or 1.05 is your R. So A1 is 30,000. To find the fourth year, that just means N is 4, and we're plugging in. And then the exponent is N minus 1, so 4 minus 1 is going to be 3. I'll write it out as 4 minus 1. So on our calculator, we'll start with that, 1.05 to the third power, and then times 30,000. So that fourth year, he made 34,728. And 75 cents. what would the total earnings be? So the total earnings would be the sum which is A1 over 1 minus R and then this is, I forgot the top part of the formula since this is not a infinite. One minus R. And this is to the n here. So this is 4. Because we're only looking at the first 4. This is not an infinite sum. So we have to do the entire part of the formula here that includes the red parentheses. So we just did, well, not entirely. So let's multiply this out. Let's do the red first, parentheses first, 1.05 to the 4th. And it's 1 minus that answer. Times 30,000. So that's our numerator, and we are dividing by 1 minus 1.05, so we're dividing by, that would just be negative 0.05 if you subtract that. So the total is 129,303. .75. So that should make sense. The first year was 30,000. The fourth year was 34,000. So the other couple of years are going to be like 31,000 and 32,000, something like that. You add up all of those. Seems pretty reasonable that you have 4 numbers that are a little bit more than 30,000. 4 times 30,000 would be 120,000, and then those a little bit more, that's where that 9,303.75 comes from. All right, and the last part is just more sigma notation. You can plug in 1, 2, 3, 4, 5, and 6 and add them up. Or much, much, much easier would just be go to Option, Calc, and find just sigma. This calculator has the little upgraded feature so we can type it in easier. Otherwise, you remember you type it in the same order. So 4 to the k. If you want to use x, you can use x. I'll use k this time though. And then next, oops, not enter. I have to use the arrows. So the next thing we're going to type in is what's the variable. So we're going to type in k, or whatever letter you choose there. And then bottom number, the bottom limit, lower limit is 1. And then that upper limit is 6. Now, if you don't have the upgraded calculator, you type them in that same order, but commas rather than pushing the right arrow. That's it. And that's 5460. All right, here's another one, same thing. Sigma, type in the equation first. We'll even do the parentheses here. 1/3. And then we'll do to the power of m. I'll change it up this time. I'm going to use the x variable. I just think it's easier. Then you would do comma if you don't have this calculator. Instead of pushing the right arrow, now you got to type in the variable again, x. And now either comma or right arrow. Bottom number is 1. And then comma. or right arrow to move up to the box, 4 for the upper limit. That's 40 over 81. That's it. So you can find your worksheet in the Files tab. As always, post any comments or questions that you might have, leave them in the discussion, and see you next time. Bye.